Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers ratio. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 12. In a class, the ratio of boys to girls is x to y. Circle the fraction of the class that are girls. Well, the total number of students in the class is going to be the number of boys plus the number of girls. And so the fraction that are girls are going to be y over x plus y then, so it's that one there. In question 4, we're given that the ratio of a to b is 4 to 3. Well, if that is the ratio, then a over b is going to be 4 over 3. Now, rearranging to make b the subject, I can cross multiply that b up there, the 4 down there and the 3 over there. That's going to give me 3a over 4 is equal to b. So b is 3/4 of a. It's that one there. Question 2. Y is 100% more than x. Circle the ratio x to y. Okay, so we always start off with 100%. So if x is 100, so x to y, if x is 100, then y is going to be 100 more than that. So y is going to be 200. And that is the same as 1 to 2. So the correct ratio is that one. Question 3. Y is 1.5 times x. Circle the ratio that is equivalent to y to x. Okay, now these are getting more and more prevalent, these sorts of questions, where you're given either an equation or something you can turn into an equation, and then from that you're meant to derive the ratio between two unknowns. Okay, so let's rewrite what we've been given in words as an equation first. Y is 1.5 times x. So y equals 1.5. Well, 1/1 is 3 over 2, isn't it? 1 over 1 and 1/2. 3 over 2x. Okay, so we've got y is equal to 3 over 2x. That's our equation in y and x. And we need to turn this into a ratio. Now, the easiest way is to get it as a fraction of one value over the other. So if I take this x here and cross multiply it down here, we should get y over x equals 3 over 2. Once it's in this form, it's really easy to rewrite it in a ratio. We can take the ratio of this one over to this one is going to be this to this. In other words, the ratio of y to x is going to be 3 to 2, like that. So it's that one there. So as I said, the easiest way I found to do these is just to try and rewrite whatever equation you've been given in the form like this of one unknown over the other, and then you can read these two numbers off here as your ratio. Okay. In question 4, we're told that the ratio of x to y is 2 to 3. So that means for every 3 y's, you have 2 x's. Now the question asks us which one of these other statements is saying the same thing. Now they all involve finding the fraction of a number. When you find a fraction of a number, you divide by the number on the bottom and then you multiply by the number on the top. So if I want to find 2/3 of y, I would take the number in of y's, which is 3, I would divide it by 3, which is 1, and I'd times it by 2, which is 2. So that one does seem to work. If I take 3, divide it by 3, times it by 2, I'll get 2. So that statement is correct. Now let's just check the others. So if I had y is 2/3 of x, well, I've got 2 x's. If I divide it by 3, I'm not going to get a very nice number. I'm going to get 2/3. Times that by 2, I'm going to get 4/3. So that doesn't work. X is 2/5 of y. Is that statement true? Well, if I take the number of y's, of which there are 3, and I divide it by 5, I'm going to get 3/5. And if I then times that by 2, I'm going to get 6/5. So that one doesn't work either. I don't have 6/5 of x. I've got 2x. And then y is 3/5 of x. Again, if I take my 2x's and I divide it by 5, I'm going to get 2/5. And if I then times it by 3, I'm going to get 6/5. So that one doesn't work either. So the only solution that is correct, or the only statement that is correct, is that first one. Question 18. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now notice that this 8 here and this 8 here are the same, so the number of shares for girls is the same, and the boys has gone from 6 to 5, so it's reduced by 1. So overall we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we will find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. At a concert, the ratio of men to women is 5 to 3, and the ratio of women to children is 7 to 4. Show that more than half of the people at the concert are men. Okay, so let's just write down what we've got. So we've got men, we've got women, and we've got children. And the ratio of men to women is 5 to 3, and the ratio of women to children is 7 to 4. Now, in order to work out what fraction of the entire team there are men, it would be good if we could write this, or these two ratios, as one ratio. In order to do that, we want to try and get these numbers in the middle the same. So if we can think of a common multiple of 3 and 7, for instance 21, and then we'll scale this ratio up so it's out of 21 women, So multiplying through by 7, that would give me 35 men to 21 women. And if I do the same with the other half, so 7 goes into 21 3 times, so if I scale that one up as well, then I'm going to get 21 women go with 12 children. Okay, so now we've got 35 to 21 to 12 as one ratio of those three things. Now, if I want to then compare what fraction are male, then I need to count up how many males there are out of the total of how many people. So, fraction that are male is going to be my 35 over my three numbers added together, 35 plus 21 plus 12, which is 56, 66, 68. And you can see the number on the top is more than half the number on the bottom. So 34 over 68 would be a half. Now, I'm just not sure if that would be sufficient for the mark scheme now. I just have a feeling that they want you to be a bit more specific about that. So I'm just going to write underneath as a half is equivalent to 34 over 68. Question 17. Naz buys a fridge from a shop for £189. The cost of delivery is proportional to the distance from the shop. So for 15 miles the cost is £9. Naz lives 24 miles from the shop. Is the total cost more than £200? You must show your working. Okay, so the cost of delivery is proportional to the distance from the shop. So we can write this down as a ratio then. So miles to delivery charge is 15 to 9. Now, using the unitary method, we would work out the delivery charge by dividing through by 15 and then timesing through by 24, and that would give us 24 miles, and that gives us one in the middle, which is why it's called the unitary method. So if I did the same on the other side, I'd be taking 9, I'd be dividing it by 15, and I'd be timesing it by 24. So what is 9 divided by 15 times by 24? Well, 9 24s is 24 less than 240, which is 216. And then how many 15s go into 216? So 10 15s is 150. We've got another 66 to reach. 15 is into 66. Go 4 times, remainder 6. So that is going to be 14, remainder 6. In other words, 14 and 6/15. Now, if you remember, we were trying to work out the total cost and seeing if it was going to be more than £200. Now, the item costs £189. So the total cost is going to be our £189 plus our delivery cost of 14 and 6/15, which you can clearly see is going to be more than 200. It's going to be 203 and 6/15, which is more than 200. Question 18. A, B and C are all positive integers. The ratio of A to B is 5 to 6 and the ratio of B to C is 8 to 11. work out the smallest possible value of a, b and c, or a plus b plus c. Let's write down the ratio of these three things together as one kind of combined ratio. So we know that the ratio of a to b is 5 to 6, and we know that the ratio of b to c is 8 to 11. So what we can do is we can try and scale these two ratios up so that the value of b is the same for both. So if I can find a common multiple of 6 and 8, the lowest common multiple of 6 and 8 is 24. So 6 goes into 24 4 times. If I take that first ratio and I times it up, or multiply it up by a scale factor of 4, then 5 times 4 is 20. So 5 to 6 is the same thing as 20 to 24. And 8 goes into 24 3 times. If I take that second ratio and scale it up by a factor of 3, I should get 11 times 3 is 33. So their combined ratio is 20 to 24 to 33. Now, none of those have a common factor, so I think these must be the smallest numbers that the three can be. So to work out the smallest possible value of these three, I can just add them up. So 20 plus 24 plus 33 is equal to 77. So my answer is 77. Question 16. A toy box contains red, yellow, blue and green bricks. 25% of the bricks are red. There are 12 yellow bricks. The ratio of yellow to blue to green is 2 to 3 to 1. Show that there are 48 bricks in the box. So we've got some, four related facts that we need to try and work out. Okay, let's start with the known fact that there are 12 yellow bricks. Okay, so y equals 12. Now we know that the ratio of yellow to blue to green is 2 to 3 to 1, so that means we can work out those at least. So yellow to blue to green is 2 to 3 to 1, and we know that we've got 12 yellow bricks. So scaling up our ratio by a factor of 6, we should be able to find out the number of blue and green bricks as well. So 3 times 6 is 18, so there are 18 blue ones. And 1 times 6 is 6, so there are 6 green ones. So how many bricks is that altogether? So 12 plus 18 is 30, so we've got 36 bricks, which are either yellow, blue or green. Now we're told that 25% of the bricks are red, so our 36 bricks which are yellow, blue or green must be the rest, the 75% or 3/4 of the bricks. So 1/4 is red, which means that 3/4 are not red. So 3/4 of my total, 3/4 of the total is going to be 36. So then the total is going to be 36 times 4. 36 times 4 divided by 3. 3's into 36 go. 12 times 4 is 48. Total is 48 as required. Gosh, there's lots of ratio questions here. 19. Rana sells 192 cakes in the ratio of small to medium to large of 7 to 6 to 11. The profit for one medium cake is twice the profit for one small cake. The profit of one large cake is 3 times the profit of one small cake. Her total profit is £532.48. Work out the profit for one small cake. So basically lots of information, and we need to work through it all to get to our solution. Let's start off with the number of cakes and the ratio. Let's start off with this line here. And work out how many of each sort of cake we have. So we want to divide 192 in the ratio of 7 to 6 to 11. So a 7 plus 6 plus 11 tells us there must be, what's that, 13, 24 shares. Okay, so then we're going to divide our 192 by 24 to work out the value of each share. So 192 divided by 24 gives us an answer of 8. So each share is worth 8. So taking our ratio of 7 to 6 to 11 and scaling up by a factor of 8. 7 eighths are 56, 6 eighths are 48, and 11 eighths are 88. Always a good job here just to double check your working. Add up the three numbers, just double check that they add up to 88. Oh, sorry, add up to 192, which they do. So I'm happy with that. So what was what? That was small, medium to large, wasn't it? So it's going to be 56 small cakes, 48 medium cakes, and 88 large cakes. Right, moving on to the profit. The profit from one medium cake is twice as much as the profit of one small cake. And the profit for one large cake is 3 times the profit for one small cake. Okay, so the ratio of their profits then. Let's say the profit from a small cake is P. Then what would the profit from a medium cake be? It would be twice the profit of a small one. So that would be 2p. And the profit for one large cake is 3 times the profit of one small cake. So the ratio of their profits is p to 2p to 3p, where p is the profit on one small cake. Now we know that the total profit is £532.48. Now again, what I'm going to do then is I'm going to divide that by the number of p's then. So I've got 56 small cakes with a profit of p. I've got 48 medium cakes with a profit of 2p, and I've got 88 cakes with a profit of 3p. So how many p's is that altogether then? I'm just going to multiply those and add them up. That's going to give me 56p. 2p times 48 is going to be 96p. And 3 lots of 88, reaching for the calculator, is 264p. So my total profit, well, how many profits is that then? So 56 plus 96 plus 264. So that gives me 416p. And I know the total profit was £532.48. £532.48. So one profit is going to be 532.48 divided by 416. 532.48 divided by 416, which is £1.28. So that means that the profit on one cake was £1, one small cake was £1.28, and obviously then on a medium cake it was twice that, and on a large cake it was 3 times that. But we only needed to work out the profit on a small cake, which we have done. Question 17. At a football game, the number of men to the number of the women to the number of children is in the ratio of 13 to 5 to 7. There are 4,152 more men than women. Work out the number of children at the game. Now there's 101 different ways of doing this, so you might have approached it in an entirely different way to me. I'm going to start by writing down the ratio that I've been given. So men to women to children are in the ratio of 13 to 5 to 7. And I'm told there are 4,152 more men than women. So if I let the number of women be x, then the number of men is going to be x plus 4,152. Now, comparing these two statements, I can see that if the ratio of men to women is 13 parts men to 5 parts women, then this 5 parts is equal to that x there. So if I break this 13 parts into 5 parts and 8 parts, then again, look, that x there is the 5 parts, and that means that 4,152 must be the 8 parts. So that means that if I take 4,152 and divide it by 8, 4,152 divided by 8, I get the answer 519. So those 5 parts of women would be 5 lots of 519. So 5 times 519 means there was 2,592 women, and there were 13 lots of 519 men. That's 6,747. So there must have been 7 lots of 519 children. So it must have been 3,633 children. So that is going to be my answer then, isn't it? That one there. So there are 3,633 children. Now, like I say, there are 101 different ways of doing this, and there are probably some more formal approaches to answering this sort of question, but at the end of the day, you've got to get the right answer, and the right answer is 3,633. Question 26. B is 2/3 of C. 5A is 4C. Work out of the ratio of A to B to C. Give your answers in its simplest form where A, B, and C are all integers. Okay, so we've got one equation in A and C and another equation given as a written thing, but anyway, we can convert that into equation. B is 2/3 of C, so B equals 2C over 3 then, isn't it? Now what? Work out the ratio of A to B to C. A to B to C. Let's take the 5A equals 4C to start with. Well, if B is equal to 2/3 of C, or B equals 2C over 3, then I can rewrite that and I can say that 3B then is equal to 2C. Okay, so we've got two equations in B and C and A and C, and we want to write those as ratios. Now this is getting quite a common thing in exams, having to take an equation and rewrite it as a ratio between two things, and students do struggle a little bit about these. Let's take this 3B equals 2C1. Now I'm going to rewrite it. I'm going to cross multiply that C and that 3, and then I'm going to rewrite it as B over C equals 2 over 3. Okay, hopefully you're able to rearrange it that way. So if I take B and divide it by C, I'm going to get 2/3, and that's the easiest form really to convert it into a ratio. So if B divided by C is equal to 2 over 3, then the ratio of B to C is 2 to 3. So if B is 2, then C is 3. We do the same thing with the other one. 5A equals 4C. So I start with 5A equals 4C, and I rearrange it the same way. So cross multiply that C down there, cross multiply that 5 down there. I'm going to get A over C equals 4 over 5. In other words, the ratio of A to C is equal to 4 to 5. Okay, so that means if C is 5, then A is 4. Now we want to get a ratio of all of these together. So can we find a common multiple? I need to find a kind of a common multiple of this number here I already found, and this one. So 3 and 5, if I make it 15, so taking this 2 to 3 ratio and then multiplying it up by a scale factor of 5, so that, and that by 5 as well, that is going to give me 10 to 15 is the ratio of B to C. And I do the same thing here. So if I take this ratio and I multiply it up by 3 and I multiply it up by 3, then I'm going to get A to C is in the ratio of 12 to 15. Then I can take this 12 that I've got here and I can write it up here then. It's going to be 12 to 10 to 15 then, isn't it? Does that cancel down? Nope. That's kind of how it is. So I've got the ratio of A to B to C to be 12 to 10 to 15. Question 4. The ratio of A to B is 9 to 4, and we're told that 10B is equal to 7C. Now we need to work out what the ratio of A to C is. Okay, so what's the ratio of A to B to C? What do we know about these three ratios? Well, we know that the ratio of A to B is 9 to 4. We know that 10B is equal to 7C, so then the ratio of B to C is in the ratio of 7 to 10. Okay, so I know that A to B is 9 to 4 and B to C is 7 to 10. So what I want to try and do here is come up with a number that's a multiple of 4 and 7, so I can express all this as one ratio, and then I can compare my A with my C. So 4 times 7 is, 4 sevens are 28. So if I make this one 28 here, then I would get that by taking my ratio of 7 to 10 and times it up by a scale factor of 4. So that means my C value there must be 4 times 10, be 40. So my ratio of B to C of 7 to 10 is the same as the ratio of 28 to 40. Now let's have a look at the other side. If I've got a ratio of A to B of 9 to 4 and I scale that up so that B is now 28, I would have times it by a factor of 7. So if I'm timesing B by 7, I have to times A by 7, and 7 9s are 63. So I've taken my two separate ratios and made one kind of combined ratio for all of A, B and C, and now you see I can compare A and C and say that then the ratio of A to C must be the ratio of 63 to 40. That's not in its lowest form, is it? Naughty me. So the ratio of A to C is 63 to 40. Can I cancel that down at all? You can actually use your fraction key to check these sorts of things. I'm just going to type 40 over 63 as a fraction and see if that cancels down. No, it doesn't. So that is already in its simplest form. So I'm just going to write that down as 63 to 40. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.